Okay, last video, we're going to look at all the graphs of the trig functions and then specifically some graphs that are, shifted and stretched and all that stuff we did with other graphs, specifically for sine and cosine. So I have up on the whiteboard here, all right, I have the graphs for sine and cosine, which we already talked about. The graph for tangent, right, we spoke about the asymptotes there. This is cosecant, secant, and cotangent. All right. Now, secant and cosecant are a little weird because they are the reciprocal graphs of sine and cosine. All right. So you'll notice where sine is 0 at pi, at 0, pi, and 2 pi, cosecant has asymptotes at 0, pi, and 2 pi. Where sine hits a maximum, cosecant hits a minimum, and vice versa. All right, so you can almost think of the cosecant graph as if I were to dot in a sine curve here, as kind of bouncing off the sine curve. Same thing with secant and cosine. And then cotangent just has that shift that we talked about for the asymptotes because it is cosine over sine as opposed to sine over cosine. All right, so these are the basic graphs. Now, before we get into doing anything else, I wanted to show you on the calculator how to set up a trig graph. Now, first things first, remember modes. All right, when you're graphing, you're dealing with x and y are real numbers, which means you have to have the calculator in radians mode when you graph. That's important. So if we go back in here, the last time we used the calculator, it was in degrees mode. So I need to change it back to radians mode. All right, now I'm going to graph the sine function. So I'm going to put in sine of x for my function. Now I need to set my window. Otherwise, all I'm going to get is this oscillating, bouncing thing going across the screen. In fact, I can prove that to you. All right, so that doesn't help me a whole lot. Right? What I would like to be able to do is graph one cycle of the sine function. So remember, we said one cycle of the sine function happens between 0 and 2 pi. That's along the x-axis here. So I'm going to start my x-axis at 0. I'm going to end it at 2 pi, and I'm actually going to say 2 pi. All right, now it's going to change it to a decimal. That's fine. If I want to, I can change my scale in here. All right, so that my x scale looks more trig. I'd like to see it actually crossing at pi. All right, so maybe I put my tick marks every pi over 2. So second pi over 2. That is not necessary. You don't have to do that. Okay. Now, my range, remember, what's the range? The range goes from -1 to 1. So I want my range to go from -1 to 1. Okay. Now if I hit graph, right, and you take a look at that, I get a nice, clean sine curve. All right. If I want to, I can go back in here, go down to my next graph, let's say, and put in cosine. And now you'll see in red, it's going to draw on a cosine curve. And it's a little bit easier to see now on the calculator the relationship between the two. If I was to slide that cosine curve to the right, pi over 2 units, it would be sitting right on top of the sine curve. Okay? I'm not going to graph any of the other ones on the calculator right now. All right, but I just want you to see that because we'll be able to use this to check some of the work that we're going to do in a little bit. Okay, so let me go back to, where's my mouse? There's my mouse. All right, so let's come back over here. Let's get a clean page. And let's look at some of the properties of the sine curve. In fact, I'm going to leave my sine curve. Right, that's right. I can't do it that way. We are not in the classroom, are we? I'm just going to leave my sine curve up there. All right. Now, we talked about the period of the sine curve. So let's come back over here. Y equals sine of x has a period of 2 pi. Okay. What else can we talk about? Well, we already know it goes, the highest it goes is 1, and the lowest it goes is -1. We call that distance the amplitude. All right, the amplitude of your basic sine curve is 1. Now, suppose I want to change that. Maybe I want a sine curve that goes up to 4 and down to -4. Think about how we did that with functions. Right? You would have to take the function and perform a vertical stretch. A vertical stretch, you multiply the function by a constant. So if I change my sine function to look like that, then what I have now is an amplitude of 4. Right? Because I've taken the sine curve that goes up 1 and down 1 and made it go up 4 and down 4. Okay. So we're starting to get a general form here. Right? And in fact, if I come over here, let me do this. We're going to go 4 sine x. Now, of course, I have to change my window because so that I'm going from -4 to 4. All right, and now what you're going to see in there is the basic sine curve, and there is my stretched sine curve. All right, so we're starting to build a general form here. So the first part of this general form that we can put in is the amplitude. We're going to call that A. Now, I'm going to put some stuff in here in a minute, so just hold on to that for a second. Now, in addition to a vertical stretch, I could also perform a horizontal stretch or a horizontal compression. Right? And remember how we did that with a function, right? By multiplying the variables. So a vertical stretch or compression is given by multiplying the function by a constant. Right? But if I were to, let's say I take this, and instead of saying 4 sine x, I say sine 4x. All right, let's see what happens. Okay, I'm not gonna change anything on my other two functions, but I'm gonna come down here now and go sine 4x. And let's see what happens with this new graph. All right, take a look at this. All right, what just happened here? Between 0 and 2 pi, I ended up with 1, 2, 3, 4. Okay, what I changed there was the frequency. All right, so the frequency of this function is now 4. What that means is 4 curves between 0 and 2 pi. All right, so if my sine curve has a frequency of 4, let's think about what that means for the period. Right? Remember, the period is the length of one cycle. So if I have 4 curves between 0 and 2 pi, that means one curve is 1/4 of that interval. All right, so when the frequency is 4, right, the period has to be 2 pi, right, the whole interval divided by 4, or in this case, pi over 2. All All right, so we refer to that frequency with the Greek letter omega. You can just think of it as a W. I'm going to stop there for now. Okay, so what we get out of this first general form, A, and we do A in absolute value, is the amplitude. And omega is the frequency. So the period, which, by the way, the book refers to with a capital T, all right, is 2 pi, whoops, hang on, is 2 pi divided by omega. All right, so this is our first, I'm just going to go with a simplified general form for right now. Now, this also applies to cosine, all right? I'm doing it for sine, but it also applies to cosine in exactly the same way. All right, so if I want to now graph, let me box some of this off here because I got some room on this page still. So let's say I want to graph y equals 2 sine 3x. All right, now I don't want to touch the calculator yet. All right, I want to see how much of this I can do by hand. All right, so I need to pull out two things. I need to pull out the amplitude, which is going to be 2. I need to pull out the frequency, which is going to be 3. And then I'm going to calculate the period, 2 pi over the frequency, to get one cycle. Anytime we talk about graphing trig functions, we talk about graphing one cycle of the trig function. All right, now, to produce this graph by hand, I know I have a sine curve, and we're not talking about shifting left, right, up, or down yet, okay? So if I mark off my amplitude up and down, right, I'm starting at 0 because that's where sine starts. I'm ending at 2 pi over 3. All right, so I'm going to put 2 pi over 3 right there. Now I know I have to have more points, right? I have to have a center point there, there, and there to draw the curve in. All right. So it would be nice if I could label these. All right. The easiest way to do it is to just midpoint everything. All right, so I'm starting at 0, ending at 2 pi over 3. So this point right here is going to be half of 2 pi over 3, or pi over 3. This point here is going to be half of pi over 3, or pi over 6. And then this point is halfway between pi over 3 and 2 pi over 3. So if I add those together, I get 3 pi over 3, or pi. Divide that by 2, I get pi over 2. All right, so I can label those points. Once I have that labeled, I draw in my key points for sine, which always follow the same pattern. All right, and then I can draw in, let's see if I can make this look halfway decent. Then I can draw in my sketch. All right, now if you wanted to verify this on the calculator, you would have to, again, change your window to match what you think the window should be, change your amplitude to what you think the amplitude should be, and then type in your function. And if you get exactly one sine curve in your window, then you've done everything correctly. All right, now let's try one of these with cosine just for the sake of doing it. So let me get a clean page here. All right, so how about we do y equals, let's throw a little curveball in here. Let's make it -3 cosine 2x, like that. All right, so we're going to pick out the same information as we did for sine. The amplitude is 3. Right, notice I'm saying 3 because it's absolute value. The frequency is 2, so the period is 2 pi divided by 2, or pi. All right, so that means I should have one cosine curve between 0 and pi. All right, so here's 0, here's pi. My amplitude is 3. All right, and let's fill in. Again, we need those extra 3 points there. These are considered the 5 key points for the function. All right, so halfway between 0 and pi is pi over 2. Halfway between 0 and pi over 2 is pi over 4. And halfway between pi over 2 and pi is 3 pi over 4. Right? So I've got my 5 key points labeled. I've got my amplitude labeled. Now I can, if I'm careful, I can do this right. All right, now remember, this was a -3. So remember what a negative does to a function. It reflects it over the x-axis. All right, so normally cosine would start up here, but because it's negative, we're starting down here. And then we're going to follow the point pattern for cosine, but upside down because it's negative. All right, and we've got cosine curve falling right in here. All right, and again, you can verify this on your calculator by setting your window to what you think your axis should be, typing the function in, and you should get one cosine curve happening within your window. All right, so now if I were to add or subtract a value to the function, that would simply shift it up or down. All right, that's not actually a difficult shift to do. It's the left-right shift, right? The horizontal shift that can be tricky with these. So let's do, I'm going to do 2 more, and I need to find my, there we go. Okay, so I'm going to grab a clean page, and let's look at one horizontal shift. So how about we do y equals, let's make it 4 cosine 3x plus 1. All right. So we pull out the information we need. The amplitude is 4. The frequency is 3. So the period, 2 pi over 3. All right, now, here's what's going to change with this. I'm going to do my xy axis just like before, and I'm going to put 2 pi over 3 at the end here. Now we already figured all these out already, so I'm just going to write them in. We did this for the sine problem. Okay. All right. Now what I have to remember here is I have an amplitude of 4, but I also have a vertical shift up 1. So what I'm going to do here is right here at 1, I'm going to pretend I'm going to just make a little dotted line here. This is not part of the graph. This is just my way of keeping track. That this is where our axis is shifting up to. All right, so this is where my horizontal axis is shifting up to. So it's from this line that I count up 4 and down 4. So 1, 2, 3, 4. So that's going to be at 5. 1, 2, 3, 4. So that's going to be at -3. All right, the sine starts right there because remember we're shifting the whole axis up. All right, and then we're going to be up here, and then down here, and then down here, and then back up here again. All right, so this sine curve is happening. A little lumpy, but it's happening right there. All right, so we just took the whole thing and shifted it up. All right, so vertical shifts, not that big a deal. We've done lots of those. Horizontal shifts, when it comes to trig functions, can be tricky, and this is where people get confused. If you're going to get confused, this is the place to do it. I actually have, hang on one second, I have a phase shift problem that we can use. I don't have it on screen. It's over here in my notes. So, all right, so let's look at a couple of things. Let's go 100% general function now. All right, so I'm going to write this for sine. This is the function for sine or cosine. All right, so it's the amplitude, sine omega x minus, all right, now we use another Greek letter here, phi plus b, and then we use b for the vertical. Now this is the same for cosine. So I'm going to write this for both sine and cosine because the information is the same. All right, so the way we figure out the shift here, all right, some stuff I can pick out right away. I can pick out the amplitude and I can pick out the frequency, which means I'll know the period. All right, but the shift can be a little tricky because it involves factoring and sometimes with weird fractions and pies and numbers, and it can get confusing. So there's a nice way of working this out, which is the basic period for sine and cosine is 0 to 2 pi. So that means whatever the argument of my function is has to be between 0 and 2 pi. All right. So if I simply solve this inequality, all right, I can find the actual period for x. All right. Add phi all the way through. So that means I'll get phi less than omega x less than 2 pi plus phi. Divide everything by omega. Then I have x. I'm going to do this in 2 steps. All right. So this is what I get now for my interval for one cycle of the trig function. Now I'm showing you this as a formula in case you're one of those people that likes to memorize formulas. I prefer it as a method. Okay. If I'm going to phase shift or do a horizontal shift to a trig function, I prefer to actually solve that inequality each time. All right, so for example, I have here y equals 3 sine 2x minus pi. All right, so there's my horizontally shifted function. So again, I can pull out a couple of things I can pull out right away, right? My amplitude is 3. My frequency is 2, which means my period is 2 pi over 2 or pi. All right, so that information I can get. What I need to know is where this starts and where this stops. All right, so I'm going to take my 2x minus pi out. I'm going to throw that between 0 and 2 pi. All right, and now I'm going to solve this for x. So I add pi all the way across. Pi. I add pi to 2 pi, I get 3 pi. Divide everything by 2. Pi over 2 less than x less than 3 pi over 2. All right, this now gives me the interval for one cycle. So when I come over here now to draw this one, I'm starting at pi over 2. I'm ending at 3 pi over 2. Okay? That is where one cycle of my trig function is going to land. All right, so if I just dot in my extra points here, right? Halfway between pi over 2 and 3 pi over 2 is pi. Halfway between pi over 2 and pi is 3 pi over 4. And this is going to be 5 pi over 4. To figure that out, all you need to do is find the midpoint. So you add your two endpoints together and divide by 2. Okay. The amplitude in this is 3, so 1, 2, 3. 1, 2, 3. All right, so what does sine do? Sine starts on its axis, and then goes up, back to the axis, down, back to the axis again. All right, so we end up with something that looks sort of like that. Okay, so it is a sine curve that has been shifted over pi over 2. All right, now this method will work for sine or cosine. You just have to remember the point patterns. All right, so let's real quick, let's look at tangent, cotangent. I'm not going to have you graph anything other than, pretty much anything other than tangent. Sine, cosine, and tangent are fair game. I'm not going to have you produce graphs for secant, cosecant, maybe cotangent, but probably not. All right, so let's look at the general form. Oh, hang on a minute. Let's try that again. A tangent omega x plus phi plus b. All right, there's the general form for tangent. All right, so again, we get an amplitude. Now, amplitude is a little bit different for tangent because if we look back at the tangent graph, you'll notice it doesn't have a maximum or a minimum point. It goes up and down forever. So you don't really think of amplitude as, it's more, you really are more thinking of it as the vertical stretch or compression than you are as a maximum point or minimum point. All right, the frequency, right? Omega is the frequency. All right, so how many happen between 0 and 2 pi? And then, or actually, yeah, good enough. And that's it for right now. All right, now the period for tangent is pi. We talked about that, which means when you have a frequency, it's going to be pi over omega, like that. All right, and when we go to solve these, so I have a tangent function here, hang on. I think I do. Yes, I do, okay. So I have a tangent function here that is y equals 2 tan 4x minus pi. Just like that. All right, I'm not going to do a vertical shift on this one. All right. All right, so I'm going to solve this one exactly the same way I did the sine function. All right, we can pick out, again, we can pick out the obvious stuff, the amplitude, the frequency, and then I can calculate the period. All right, like that. To get where I start and where I end. Now remember, with tangent, where you start and where you end are asymptotes. So what I'm really looking for here are the asymptotes. All right, between which I will have one cycle of the tangent function. So my argument for x minus pi comes out. Now, For tangent, where are the asymptotes? They are at negative pi over 2 and pi over 2. All right, go back and look at the graph. So I add pi all the way across, so I take pi plus a negative pi over 2, gets me pi over 2, 4 pi. Pi over 2 plus pi gets me 3 pi over 2. All right, divide, wait, that's an x, not a pi. All right. I divide everything by 4 to solve for x, and I get pi over 8 less than x less than 3 pi over 8. All right, so when I go to draw this one, all right, so pi over 8 is pretty close to 0, so I'm going to throw my asymptote in over there. 3 pi over 8 is actually pretty close to pi over 8, so throw another asymptote there. So pi over 8, 3 pi over 8. There's a point right in the middle. All right, so if we add pi over 8 and 3 pi over 8, that's 4 pi over 8, which would be pi over 2. Divide that in half, that would be pi over 4. All right, and tangent goes up on the right, that's an asymptote. Goes down on the left, that's an asymptote. And that would be your graph. All right, so just to sum this all up here, all right, let's make a little summary page here. All right, so for sine and cosine, all right, so for both sine and cosine, you have the amplitude is the absolute value of A. You have the frequency, which is omega, and you have the period, which is t, which is 2 pi over omega, and you have the interval, which is going to be from 0, what's inside, to 2 pi, solve for x. All right. For tangent, all right, again, A tan omega x minus phi plus b. All right, you have, again, the amplitude. Is A. The frequency is omega. The period, which is t, is pi over omega. And the interval is going to be 0. Nope, it's not going to be 0. The interval is going to be negative pi over 2 less than, again, whatever's inside, to pi over 2, and then again solve for x. Okay, now, in terms of what I want you to do in the book for practice, let me get to the problem set, hang on. Whoop, too far. Okay, work on, don't work on those are matching problems. Work on these, graph each function. Okay, so start here, all right, page 420. Take a look at 33 through 56. Those are all just sine and cosine. All right, then excuse me while I flip pages here. Okay. There's some tangent graphs here you can work on. Just work on the tangent graphs. Okay, so let's say 17 through 22, just the tangent ones. Okay. Now, these are the phase shifted problems. So this is the real guts of what we're doing here. Okay. So the phase shifted graphs are right here on page 439, 3 through 14. All right, those are all sine and cosine. I'm pretty sure that's all they give you here. All right, and then there's some tangent ones here as well. Okay, so you could also look at 19, 24. Yeah, just stick with those. All right, don't go outside of those. All right. Okay, so I am going to put together an online assignment, and I am going to get that up, and I will send an email out as soon as that is ready. In the meantime, just go through these 3 videos, work the problems in the book. I will have an assignment up by probably by Saturday. Okay, and enjoy your spring break.